Well, good morning, good evening, and good afternoon, everybody. Thank you for joining us today for a discussion on the impacts of the 5.9 gigahertz spectrum reallocation on the Smart Columbus connected vehicle environment. I'm Frank Perry, a technical principal of CAV at WSP. I've been part of CAV standards development since 2004 and led the USDOT DSRC proof of concept testing in 2007, 2008. Also led the DSRC device interoperability testing for the safety pilot model deployment in Ann Arbor, Michigan in 2012, as well as several other DSRC deployments. WSP is leading the CV environment verification for Smart Columbus. So next slide, please. Okay. So I'm sure everybody is aware of the FCC NPRM. It was released in November of 2019. And as currently written, it would provide the lower 45 megahertz to unlicensed devices such as Wi-Fi. The upper 20 megahertz would then be reserved for C-V2X, leaving DSRC with one 10 megahertz channel, channel 180. Shortly after the NPRM was released, the FCC restricted all DSRC FCC licenses to only channel 180. Smart Columbus was in the beginning process of device integration when the NPRM was released. So we decided to move all V2I messaging to channel 180 to comply with the new FCC license restrictions. So the presentation today will discuss the impacts in Smart Columbus of using only one channel for the entire DSRC system. So joining me today is my colleague Ryan Bollo at the City of Columbus. He's the CV project manager, as well as my WSP colleague, Timcho, who's the overall project lead for the Smart Columbus connected vehicle environment. And my role on the project is test lead. So next slide. Okay. So today's agenda, we'll have Ryan Bollo be talking to us about, or give an overview of Smart Columbus in general, give us an overview of the impacts on FCC licensing to only get channel 180. And then Tom will be talking to us about the overall impact on the CV system using channel 180, and then I'll give an overview of channel 180 impact to testing, and then we'll have some lessons learned. So with that, so Kate, has Ryan been able to join yet? Does it look like it?
He is working with tech support and hopefully will be with us shortly.
Okay, thanks. So next slide, please. So Tom, do you want to start us off on the Smart Columbus overview?
I can. So while we're waiting on Ryan to join, I'm happy to get started here on this. So why don't we go ahead and advance to the next slide. So there are a lot of disruptions happening in technology, transportation, and data. The U.S. Department of Transportation saw this and knew it was an opportunity for cities to think differently about how they manage those disruptions when they issued the Smart City Challenge in 2015. It was geared for mid-sized cities up to 800,000, and Columbus was one of the 78 cities to apply for the grant. In 2016, the city was fortunate enough to win the $40 million grant from USDOT, and that was in combination with the Paul G. Allen grant for electrification, that's a private sector acceleration fund that helped to springboard innovation, electrification, vehicle chargers, and so on in the city. Overall, the vision here is to empower our residents to live their best lives through responsive, innovative, and safe mobility solutions. The mission is to demonstrate how an intelligent transportation system and equitable access to transportation can have positive impacts on everyday challenges faced by cities. These outcomes are outcomes that are any municipality should be driving towards, and we are seeking long-term outcomes that will make our city a great place to live, work, and visit. Next slide, please. The USDOT portfolio is broken down into 3 distinct themes of projects. Enabling technologies, which is leveraging existing technologies in new ways. And that is where our connected vehicle project that we'll be speaking of to you today lies. We also have projects related to enhanced human services, which really entails connecting people to jobs, opportunities, and services through technology. And lastly, we have emerging technologies, which is the cutting edge technologies like self-driving vehicles. Kind of interesting to say is when we thought about it, connected vehicle wasn't considered an emerging technology. It was really considered an enabling technology because of where we had advanced already at this point. Channel 180 threw us for a little bit of a loop on that when we had to come back and say, well, now it's kind of back to emerging as we reevaluate the ability to do this. All of these projects, however, are anchored in our Smart Columbus operating system, which is the backbone of the entire program. And that is really our data repository. And that's part of the city's long-term strategy. So as all these projects come together and bring data to the system, it allows us to make decisions and see how everything is performing. So let's go on to the next slide. So specifically for the connected vehicle environment, everybody, I believe it's on the call, understands what connected vehicle is. Vehicles talking to vehicles and to infrastructure for purposes of safety and mobility messages. The city currently has 3 contracts to deploy the project. So there are 2 systems engineers, one for the onboard units, which is led by Siemens, and one for the roadside unit integration, which is led by Capsch. And then there is an installation telecommunication contractor to perform all of the network hardware installation along the corridor. So this is all based off of a fiber backbone that was part of the city that is now being expanded on to include the connected vehicle environment. I'm not going to get through all the statistics here, but you can kind of see the numbers that we're talking about for the project here, in particular the CVE. So 90 plus roadside units, and we're targeting 1,000 to 1,200 OBUs, which are divided up amongst private and public sector vehicles. We also have some other projects that I didn't mention previously, but the Smart Mobility Hub, which are located in 6 locations, and that helps bring together various modes of transportation, such as bike shares, scooters, ride share, at drop-off points where there are also Wi-Fi kiosks and touchscreen kiosks and so on. And then the connected electric automated vehicle, which actually there have been 2 in the city. The first one was a very early deployment using May Mobility in our downtown region. That was really meant to be kind of a data gathering exercise to understand what's available, what do we have to do to prepare for it. We've now moved to our second deployment, which is what we call the Linden Leap, which was originally designed to move passengers between a community center and our bus rapid transit line that runs through the corridor. But due to COVID, we had to rethink that, and is now moving people in a food pantry. Next slide, please. So the other projects in the software, and these are mostly, the other projects in the portfolio, which mainly include software, are the operating system. Like I said, that's our big data exchange, and that's where we do the analytics and visualization, and that's available to anyone that wants to use it. They can go out to smartcolumbus.gov and they can find the link to the operating system and mine the data. We also have some other projects here that are focused more around the enabling features for people to more efficiently move through the transportation system. Won't get into all of those, but we have one for mobility assistance, a multimodal trip planner, a event parking management system, and then finally a prenatal trip assistance project. Next slide, please. So let's talk a little bit more on the connected vehicle environment. So specifically, let's talk a little bit about some of the quantities, just to give you an idea of the types of vehicles and so on that we're using. So there are, say, roughly 1,066 targeted vehicles at this point in time, and you can see the type of fleets that we're looking at here. I know you can't see my cursor moving through the screen, but I'll step down through them quickly. Is that we primarily have 4 classes of vehicles. We have light duty vehicles, which include a mix of private sector, public sector vehicles, as well as our local transit agency. And those vehicles will have all the V2X safety applications that we expect to deploy within the corridor. They also have a heads-up display to communicate the information. And then there is, but there are no data logging or any of that for these particular vehicles, which is unlike some of the other pilots. Now, all the basic safety messages that are generated by the vehicles will get communicated over the RSU, but not by capturing logs on the vehicles. We also have emergency vehicles, which will include both fire and police. Those are using emergency vehicle preempt, and that is throughout our installed corridor. We have heavy duty vehicles, which include both private duty freight vehicles with our partner ODW Logistics and their subsidiary Distran. And so we have roughly 14 vehicles there, along with our county engineer offering up a few vehicles. And then lastly are the transit vehicles, which include the CEAV I spoke to earlier. And then also our CODA fleet, which includes roughly 320 buses, of which 15 will be equipped with transit signal priority. Those do not have heads-up displays, but they are running they are still running all the applications. These are actually being logged, and the data from those are being captured. But as you can see, a lot of different vehicle classes, a lot of different combinations, and so on. I see Ryan has been able to join. Ryan, are we hearing you okay?
Can you hear me okay, Tom, or not?
Yes, I can. So do you want to go ahead and take it from here?
Yeah,
sure. I see my video's frozen. I went to a really old laptop since my work laptop didn't seem to have a mustard enough to do what we needed to do. So, all right, see, we're on vehicle classes, and so we'll go to the CV apps then.
Yes.
Okay, let's go there then. All right, so we used 8 use cases to correspond to the applications seen here that were deployed as part of the CV environment. They were to improve vehicle operator safety, improve the intersection safety, reduce speeds in the school zones. We really wanted to improve the reliability of the transit vehicle schedule adherence because it's so important for people trying to catch the bus to not be too early, not to be too late. Improve the emergency vehicle response times because we always want them to get there quicker. Reduce the wait and delay the times for trucks, vehicles, freight vehicles at signalized intersections that you start and stop, they're polluting the air. We want to have them get through the corridor as smooth as possible to get to the interstate where they can really do some good. And then for our traffic management folks, we wanted to have that capability to improve our management, get more data in there, look at the numbers, and see what we can do to make signal flow better, reduce accidents, and improve safety. And then for our transit partner, CODA, we wanted them to have the ability to look at more data sets to see how their drivers and their routes and their fleets are operating. So on the whole, the CV projects intended to improve safety for vehicle operators, reduce that delay, and provide operation data to complement what we already have. And we'll put that all in the operating system. We have 3 classes of applications in this table, the V2V safety, the V2I mobility, and the V2I safety. You can also see the applications and associated vehicle classes identified along with the traffic management classes. There's a lot more granular deep dive we take in this, and it's captured in our concept of operation document with a webinar we did on the Smart Columbus website. So let's go to the next slide. So these are some of the alerts that we displayed on the heads-up display that Tom probably touched on for the light-duty vehicles. The top left is the blind spot warning and lane change warning. It's activated on either side of the vehicle. We just happen to show the icon here for the driver's side. The top middle is activated by electronic emergency brake light warning, and it displays differently from the point of view. The rest, because it's being activated by a vehicle not necessarily in front of you, but a vehicle or 2 ahead, since they're talking V2E. So that's why it's in that approach. 4 collision warnings on the top right, and pretty self-explanatory. The reduced school speed zone is activated when a connected vehicle is in an active school zone and the speed is over that 20 miles per hour. So we are getting real-time information of when a school zone is active from the schools from the system that operates it. So if there's an early release, we know about it. If school's canceled that day, we know about it. So we won't be giving false readings out there for someone going through that zone. The red light violation warning also is out there, and it's critically dependent on the map messages and the spat coming out of the signal controller. So we work with the Franklin County Engineer's Office to make the maps accurate as possible. They surveyed things, they GPS things. We made our map messages so they're extremely accurate. We don't have to go out there and redo them again and again. And then the bottom right was the intersection movement assist. And Tom and I had a fun time doing that because I was always driving a vehicle that was going to be hit. He was basically the battering ram. So I was a little intimidating at first, but after we got it down, it was pretty good. So let's go to the next slide. So as we were developing our Smart City Challenge application, we're reviewing the crash data in neighborhoods with the transportation needs and all the assets there. This map shows Cleveland Avenue, which is the eastern north-south route corridor, which crosses through one of our opportunity neighborhoods, the Linden area, as well as one of the city's greatest transportation assets, the Central Ohio Transit Authority's CMAQ or BRT line that was mentioned earlier. So this corridor is very critical for jobs, getting people to education facilities, getting them to the doctor's offices, and places all of us need to get to. This corridor also had 18 of the top 100 high crash intersections between the years 2016 and 17. And as we did the application, we found out that this area here, these corridors, the High Street, which is the western north-south route, and the Morse Road northern east-west route, we had 3,000 non-intersection related crashes along these corridors with 860 or so injuries and 3 fatalities, and 2,400 crashes reported along those corridors. It was ridiculous. So those rear end angle side swipe crashes were the greatest number that we had there to go with the injuries and fatalities. And in the bottom right inset there, that shows the Allen Creek corridor, which supports a high volume logistic area with heavy duty freight vehicles near the cargo dedicated international multimodal logistic hub, Rickenbacker Airport. So overall for the project, we have about 20 miles or so, a little bit more than that, of roadway equipped with CV technology on the roadside. And to support the project, we leverage our investments of the 400 plus miles of fiber optic cable we have around the outer belt, along the interstates, and on the corridors as part of our traffic signal system projects that we've done over the past decade. Connect about 850 signals. We're going to get to about 1,200 when we're done. So we already had a good foundation and redundant network. So we really just had to do the fiber drops to the intersections to get the communications going and get the electronics installed. So ultimately, this slide identifies the applications you saw earlier with the little colors and the features at locations. And you can also see the police stations and the fire stations as well. Let's go next slide. So now that you have a background of our project, what we're doing, and some of the other projects that we have, let's go over the FCC site and what I went through as I developed the applications and got the licenses. So let's go next slide. So this is an overview of the FCC site here. After you register the FCC, you'll receive a login and be able to review all of your information on an overview screen like this and see what licenses you have. So as you can see on this screen here, I have 2 licenses through the FCC for the City of Columbus. One's the 5.9 gigahertz IQ, and the other one's for public safety band, the 4.9 gigahertz, the PA. So those are the 2 that I have with the city, with the FCC. Next slide. After you register the FCC for a license, and I had to talk to some people, Tom and companies and some RSU vendors to figure out exactly what to do. But after you register for your FCC license, you have to go to License Manager and select the type of license to be submitted. In this case, like I said, is IQ GSRC. You have to first have an area approved by FCC before you can put in your actual locations. So before October of 2019, you could select which frequency range you wanted in the band. So it would list them all there. You could choose which channels you wanted, so if you didn't want them all. So when I originally received approval in 2018, I had a 0.9 kilometer radius around the downtown area for a small portion with the entire 5.9 band, so we could do some testing there on one site near our experience center. So in October 19, I wanted to update the license or submit a mod in to increase my radius to encompass the entire area of the project that was needed for the CVE project. Increase the limits. So previously, when I worked at FCC with the 4.9 band or 5.9, it took about 2 to 3 weeks to get feedback, and it usually would come by mail. This time, when I submitted in October, it didn't. Now, you can see in that drop down, there are different options. You can do a countywide, a national one. You give a narrative of something else. You can make a box rectangle. You use statewide or just whole continental US. For Columbus, we're going beyond our Franklin County area. So it didn't make sense to do a county one like I do for the 4.9 band. It would make more sense to still have another center point and expand to about 20.5 kilometers. Next slide. My screen's blank. Is it up?
No, it's still loading.
Okay. So I see a little broken symbol in my top left.
Yeah, it looks like the image is not loading for this slide.
Okay. Well, I'll describe it then, because I'm an engineer and we're really artistic at describing things. So what we have here, if let's see here. Can you try the next slide? I could kind of talk to that. So what we had before that should have been displayed was a map of the Central Ohio area.
Yeah, Kate, looks like we've lost the presentation.
Yeah, I just see us now.
Please stand by while we work. There we go.
Well, that looks familiar. All right, so I was going to describe it, but now you can see it for yourself, so that's better. So that green area is the approved area of operation that I now have. The little markers in the blue ones are the registered locations. But like I said, this didn't really happen in the 2 to 3 week time frame that I was usually getting feedback with the FCC. In the beginning of November, I decided to contact them to find out why my larger area mod was not moving forward. But I received feedback that it was simply in review. Shortly after that, the announcement came out that the proposed redistribution of 5.9 band occurred. So I followed up in December with them as well, but I did not receive any guidance on what to do.
Yeah.
Then the public notice came out on December 19th, the DA 19-1298, and it stated that only applications for channel 180, the 5.895 to 5905, would be accepted. Now, being a government employee, I decided I might want to wait till January 5th to start submitting anything back to the FCC, because I know during the holiday season, we're very understaffed. So I submitted in January. I call a couple of days later the FCC representatives and explain the situation, because I find it's best to talk through a challenge instead of just emailing back and forth and corresponding that way. So after discussing the December 19th direction that was given, they asked me to add an attachment to my modification and basically write up the request of why I was expanding the area and that I was dropping all the other parts of the 5.9 but the channel 180. Expand the radius, drop all the other channels, and way I send it in. Next slide. So that got approved very quickly a few weeks later, about 3.5 weeks. So I started sending in my individual locations. And you can see in the slide here, I'm on, 61 through 70. I send in almost 80 of them or 90. After this first location was approved, and I talked to them again, I had no problem with the rest of them. So I would space them out. I'd do like 7 a week so I didn't overwhelm them, and submit them all in, and they just turned around very quickly. And I was also noticing that FCC site also sent updates on my dashboard, basically, when I went to the overview screen here of new changes, and I could click on them, as well as receiving them in the mail later on a few weeks afterward. Next slide. So here's a listing of, you can see the order I submitted stuff in. That Civic Center Rich was that one that was downtown back in 2018. And then I submitted Cleveland and Elmore, Northern Lights, Ennis, and way down the line. So you can see our lat longs that are there, our azimuth, everything you need. So it's very handy on the site to be able to look by a call sign, go to the individual locations, hyperlink it, and get all the information that you've entered in case there is a change. So go to the next slide. So when you look at this screen, this is at the very bottom, you can see the file number. That's a PDF of all the information that was entered into the application itself. So you can see the number of items that you need to really know. The most important thing to me was finding out the mounting height of the RSU. If the mounting height's greater than 8 meters or 26.2 feet, you're going to have to reduce the EIRP, effective isotropic radiated power, by taking the height in meters that you're planning to mount it and divide it by 8, and then 20 log it. You take that number and subtract it from the maximum EIRP of that channel. Now, as Tom went through and checked things for me, we found out that channels 172, 174, 176, they all were at 33 dB. Well, channel 180, its maximum is 23. So this really made us think about if we're going to put something on a high, tall bracket arm, if we're going to put it on a mast arm, or we're going to put it on a 6-foot arm coming off a signal pole, or what we're going to be. So that was critical. And also noting that the highest you can have an RSU mounted is 15 meters or 49.2 feet. You also need to know the elevation of the location above sea level, the type of pole, the antenna manufacturer information, and you get that. We have Siemens, Cash, and Danlaw, so I got their antenna information for all of them. So every individual site is unique for their RSUs themselves. If I ever have to switch one out with a different manufacturer, I'll have to go back in and make a change and enter in that information for those particular radios. The maximum power output of the radio, all the other necessary items that you see there, and you can look at that file number and see that what was entered in at the time. So we have the licenses for all the locations now, but that was only part of the story, because now we know there'll be impacts to the overall system of just using one channel and having reduced power. And Tom's going to discuss that there. Tom?
All right, thank you, Ryan. So if you can move to the next slide, actually, we'll go through 2 slides. So just a little more background, and Ryan talked to some of these here, just to give you some context of what we're dealing with here. So we have 3 RSU manufacturers that are part of the integration here in Columbus. That includes Koppsch, Danlaw, and Siemens units. There are also 2 signal controller manufacturers that are in play here, which include the Conlight and Siemens. Now that's not as critical, obviously, because at that point we're not dealing with the channel 180 issue. Then we do have the 1 OBU manufacturer at this point. And then 1 message handler, and what we're referring to by the message handler, if you think about it in terms of like the V2I hub or the V2X hub. So that's the in-between that is being used here. Okay, next slide, please. The other element we have are the CVE systems, and what I refer to as the systems are basically those elements that are different than the roadside hardware themselves. So we have a CV management system, and that's what you see a screenshot there is, and that allows us to have an inventory of all of the devices that are in the field and then what their status is. It allows us to monitor whether or not they're actively transmitting, and also to load things such as a map message and so on and so forth. We also have a transit CV management system. Earlier, I spoke to the fact that the transit vehicles are collecting data. The transit CV management system is that system which enables that collection of the data from the transit vehicles. We have a position correction system, that is used to provide RTCM data, the vehicle or GPS position correction information to the vehicle. And then lastly, a school zone system. So all these systems integrate into the ultimate system. Why are these important? Well, there's a lot of complexity here. You've got a lot of different elements that are looking for bandwidth, both on the backhaul, but more importantly on the over-the-air interface as well. So let's move on to the next slide, where we'll talk specifically about our channel allocation. When the project was first conceived, and even when the original procurements were let for the two systems integrators that are part of this, the plan had been to go with, I'll say, the traditional DSRC model. So we had all of our safety on channel 172, which included the basic safety messages, SPAT, MAP, and RTCM, and those supported the applications such as red light violation, and then all of the vehicle-to-vehicle type of applications. I'm going to jump down to just speak to 178, as if you're familiar, was the control channel, and on that channel we had the wave service advertisements as well as the TIM message that was used to support the reduced speed school zone. So those were the two primary channels. It's a two radio OBU that we're using, as well as a 2 radio roadside unit. Obviously 172 was fixed for safety, 178 was a control channel. And then we had allocated, based on our deployment, we were intending to use channels 174, 176, and 180 to support the other remaining features here, which included all of our signal priority and preempt, as well as the over-the-air updates for the onboard units, and lastly, any kind of certificate top-off that would be there for the SCMS. And these were determined by what is in the wave service advertisement. So, channel 178 will tell you where to find the TSP capability. So the signal requirement or signal request message, the SRM, and then the corresponding signal status message. The reason why I want to point out one key piece here is the over-the-air updates is very significant to our environment, because we've really looked at this being a deployment, not a pilot. So all of the vehicles, once they leave installation, are really intended to not return to any facility for anything in terms of any upgrades. So any firmware upgrades that would have to happen to the onboard unit need to be enabled via over-the-air updates. Now, we don't have the bandwidth requirement of trying to pull down logs over the air, as some of the pilots do, but still we have the over-the-air update to the firmware of the devices, as well as the certificate top-off that would occur. So that is where we would expect a lot of the high band. So let's move on to the next slide, which talks about our revised channel allocation plan. As Ryan spoke, we were basically could not pursue a path of staying with that model, even if we had wanted to, given the FCC licensing restriction on this, and the city was not interested in violating that licensing. So we pivoted to a simple or a single channel model for all of the messages, with the exception of the basic safety message, because the onboard units are still licensed under a different part of the code, and because that part has not yet been there's not been any real dialogue of any significant. There hasn't been an NPRM to revise that piece of it, if you will. We made a decision collectively with USDOT, the city, and all the partners to move forward with safety remaining on 172 for the purposes of V2V. So all the V2V is still on 172, but everything else had to move to 180. So that included all the safety for V2I, so SPAT, MAP, the RTCM, all the mobility services for signal request and signal preempt, as well as the over-the-air updates and SCMS. And what's shown in the applications, but not even in the messages list, is also the wave service advertisements to make vehicles aware that these various services were available, and where to get the endpoint addresses for the OTA update and the certificate credential management and so on. So that was the move. The pivot was to put everything on channel 180. Next slide, please. So what do we do about it? So we had some questions here. So what do we do about the various things? For instance, wave service advertisements. You know, in a normal environment, as we said, channel 178 would have the wave service environment, wave service advertisements, and those would redirect you to other channels in the spectrum. You know, do we need a WSA, given that all the messages are on the same channel? Said the decision was made to go ahead and advertise on 178 those services which would not normally be expected on, no, I'm sorry, not on 178, on 180, but those services which would not normally be expected to be on what we'll call a control channel in this case. So the road sites, or the SRM for this signal request message, the signal status message, and the endpoint for IPv services are all part of the WSA advertisement that is deployed on channel 180. Congestion concerns. So will OTA or certificate download prevent SPAT, MAP, TIM, and others from being broadcast? Well, we don't know the answer to that yet. We're still exploring that. That's part of our testing and evaluation we're doing. You know, our environment is not tremendously large, but you know, we do feel we have you know, a significant amount of vehicles that would be taking aware of the advantage. And we're kind of caught in a dilemma here. Is that, you know, our goal is to be successful, and we do believe that we'll be able to be successful within the scale of our environment, but we really aren't sure how well this will be scalable going beyond that. You know, we're looking at possibly 4, 5, 6 vehicles at a time interacting with a given intersection, asking for SPAT, trying to do OTA and certificate updates, but we're not asking for 20 or 40 or more. That could be really a possibility of the future. So do we think we'll be successful? Yes, we do. But again, we just don't know how scalable it will be. And the other challenge is regional interoperability. You know, the obviously within the industry, there is still a large amount of folks that are very interested. We're trying to preserve the spectrum, the full 75 megahertz. You know, but in terms of moving forward with this project, we needed to pivot to 180 so that we could move forward and demonstrate the successes that we could find, and generate the lessons learned and capture the data that is part of the target here. But with that, there is some sacrifice on regional interoperability that still has to be resolved, as there are other deployments in the region that are still based off of the multi-channel 172, 178 model. So for now, that's you know, just an issue that we have to agree to disagree in the sense of how those have moved forward, and you know, continue with Smart Columbus the way it has. So last slide of my part. So just want to speak a little bit to the overall schedule impact. So, you know, the overall schedule impact, you know, there's a couple things here. You know, it added approximately a month of staff time to implement the changes. So, you know, fortunately, you know, this was not overly challenging to go ahead into each of the respective software firmware from the various entities and implement that. So we'll estimate it's roughly a month. You know, at the same time we were doing integration, we were also working on solving other problems, but you know, we had to go back in, and you know, that's the estimate for what it took to make the changes to the firmware to support this. Now that translated to roughly 3 months of elapsed time, just because of the cycles here. You know, I indicate that it required 2 integration cycles. So, you know, we had you know, we were actually in the midst of doing integration in November when the NPRM came out. You know, and at that point in time, we didn't know how to react to it in November 15th, I'll say. So, well, actually, I think I have it on the timeline on the next slide. But you know, when we started that, we then, you know, started moving forward with making the changes. You know, we had a next get together that required, you know, that we started to sort this out, and then lastly, you know, our most recent one. So let's move on to the next slide where I can show the timeline. So So just to give you a timeline on the project to where we are and where we're going. September of last year was when we first had the integrator kickoff meeting. So we got together, started talking about how to overcome, and integrate all the applications. November is when the FCC NPRM came out, as well as the integration activities that we were still doing on 172, 178. In February, we had pivoted to channel 180. In March, COVID, of course, hit, and that put a slowdown on everything. But in July, we had gotten back to a point where we were doing application verification, for which we were successful in verifying the applications using this single channel model. Had a few tweaks, and in August, we were doing the application retest. And now here in September, we've started our private installation. So we are still in the midst of trying to test some of the congestion and the bandwidth limitations possibly of channel 180. But from a functionality standpoint, we feel that we have been able to demonstrate and have been successful moving forward with a channel 180 solution for this. So with that, I will turn it over to Frank. Oh, I'm sorry. I guess I had one more slide here, but I think I've spoken to all those. They said the current scale was supported, larger scale. We really don't know interoperability to be a challenge. And then, whatever the FCC ultimately decides on DSRC and whether it has a life or not beyond this. So sorry about that, Frank.
Okay. Yep. Thanks, Tom. Next slide, please, Kate. So I want to. This is an overview of all of the testing that we need to do for the entire system. So as Tom mentioned, we have 3 different RSU suppliers. They each need to be tested against the message handler, the OBU, the FCMS, and the overall CVE network. The message handler needs to be tested against all 3 RSUs, the 2 signal controller manufacturers, the connected vehicle management system, the overall CV network, the position correction system, and the school zone system. So we have a lot of moving parts here. On the OBU side, we have to test them against each one of the 3 RSU manufacturers. The transit connected vehicle management system, again, as Tom mentioned, transit vehicle OBUs will offload their data to that.
Did we lose Frank?
It looks like it.
Okay. Why don't we give him a few seconds here, but I can speak to the testing overview. Well, I will try to pick up where Frank left off. So, as you can see, the testing overview here, I'm not going to go through all these, but there were testing elements. Oh, Frank, you're back.
Right. Yeah. Apologies. My Chrome just decided to close all by itself. So, as I was saying, so the OBU needs to be tested against the 3 RSU manufacturers, the transit connected vehicle management system, the FCMS, the OBU firmware server, the overall CVE network, and of course all of the applications. So next slide, please, Kate. So really, we had 3 main test objectives around channel 180. The first one is just to make sure the RSUs can broadcast all of their messages on channel 180 at the appropriate rate, at the appropriate times, et cetera. And from the OBU perspective, similar kind of test. Make sure the OBUs can receive all V2I messages, perform firmware updates, certificate top-offs, everything on channel 180. And then really, we need to confirm that an OBU performing firmware update or certificate top-off will not impact the V2I applications, and specifically the ability of RSUs to broadcast the other messages. So next slide, Kate. So here's a summary of the test cases for each of the devices. So from the OBU device standpoint, you see we have 28 test cases identified. 6 of those were updated because of channel 180, and this is really just making sure devices can broadcast and receive messages and perform OTA on channel 180. We added 2 new test cases, and these were around doing signal priority requests and again OTA on channel 180. From the OBU application standpoint, we have 15 test cases, 2 of which were updated because of channel 180, and really these revolved around the 2 V2I applications, red light violation warning and reduced speed warning. We added 8 application test cases, and these were really around channel congestion, so making sure that the entire system can operate on channel 180 when we're downloading firmware updates or performing certificate top-offs. The RSU, we have a total of 17 test cases, and 11 of those were updated because of channel 180. And again, this was just to make sure that the RSU could broadcast everything on channel 180. As I note down there, so updated tests really focused on single devices operating entirely on channel 180. The new test cases focus around channel congestion. So next slide. So here's a snapshot of some of the tests that we came up with around congestion for channel 180. We started things off simply. So the number in the cell there, that's aside from the ID number, those are the number of devices that are broadcasting a particular message. So as you can see, we started off really simple, want to do a transit OBU doing signal priority request, while to an RSU that's also broadcasting all of the other messages. So WSA, StatMap, TIM, and in this case, SSM. Once that was completed, then we moved down. We had the transit OBU, again, do signal priority request, but this time we also wanted to download a firmware update with the RSU broadcasting all the appropriate messages. So once we get through that, then we'll move on to the light duty vehicle OBU, same kind of process. We start out with just having the OBU run, one of the V2I applications, in this case, red light violation warning, while the RSU is broadcasting all the other messages. And then we add that OBU to do a firmware download. And then the next step is we have a light duty vehicle OBU and a transit vehicle OBU running or doing their respective V2I applications. Again, all against the same RSU, broadcasting all of the messages. And then from there, we move on. We add in OBU doing the transit OBU doing a firmware download while the other 2 devices are running their respective V2I apps. So next slide, Kate. Okay, so we kind of, I'll say end up here with we have one light duty vehicle OBU, 1 transit vehicle OBU, both doing the firmware update, both running their respective V2I apps. And from that point, we just add in additional light duty vehicle OBUs running the V2I app and then doing a firmware download until, in this case, we kind of end with 5 OBUs total running the apps and then doing a firmware download. And again, really, this is to verify that an OBU doing a firmware download or doing an intensive data exchange will not affect the RSU's ability to broadcast other messages or the OBU's ability to receive those other messages. So next slide, Kate.
And I think we lost Frank again.
Okay. So So from a testing status, I said I alluded to some of the testing we had done earlier. So we've had several formal test sessions at this point in time with the city team, and the RSU and OBU device integrators. There have been many informal sessions, especially during this COVID environment, where we're remoted in and ran different types of tests. To date, these have focused on the integration of the roadside unit with signal controllers, that message handler, and the transit connected vehicle management system. It is focused on the RSU message broadcasting and the OBU functionality, and as well as the OBU's firmware update capability. And then most recently is getting the signed message elements of this under tested. So next slide. Kate? Oh, very good. Thank you. So this gives you a breakdown of the overall testing. There were a total of 28 test cases for the OBU, and as you can see, the percentage of those is roughly 39% complete. We're still working on some of the channel 180 broadcasts, or I'm sorry, for the signal request message. And then the OBU applications are roughly 40% completed. So we have 7 of the 15, and roadside unit and other tests. Bottom line, we're roughly about 45% through the formal testing of this, of which the majority of what's remaining has to deal with the formal channel congestion element of this. So we, I said, we have demonstrated that we can operate on the single channel, but not with any type of scale and not with multiple applications hitting it at once. So I don't know what Frank's last slides look. Is there one more slide, Kate?
I'm back.
Oh, okay.
I'm back. Yeah, apologies. I must be having issues with my internet connection. Sorry, Kate, can you back up a slide? So go forward one more to that table. Thank you. So here's all of the test cases. I mentioned earlier, for the OBU we have successfully completed 11 of the 28 test cases, 7 of the 15 OBU application test cases, and then 10 of the 17 RSU test cases. So again, testing today is really focused on single device application testing, operation on channel 180, and then the V2V application. Formal congestion testing really hasn't been conducted yet. So next slide, Kate. So here's what we have been able to do from a channel 180 congestion standpoint. We've done the what I'll call the simple things, right? We have the transit OBU requesting and receiving signal priority on channel 180 with all the other messages on 180 as well. And we've done red light violation and reduced school zone applications on light duty vehicles. And then we have also done all 3 of the V2I apps, so that's red light violation, reduced speed, and then SRM with the RSU broadcasting all the appropriate messages. So next slide, Kate. So a couple of lessons learned. With a couple of exceptions, I think all of the devices broadcast and receive messages, kind of out of the box. So when the devices were configured by the manufacturer or the device integrator, they shipped them to Columbus. We unpacked them, set them up, and they began broadcasting. OBUs began broadcasting VSMs, RSUs began broadcasting appropriate WSAs. So that was all good. We did have a couple of instances where we had some data, some content mismatch in the messages, where the OBU was expecting certain data elements that weren't there, or vice versa, that certain data elements were there that the OBU app wasn't expecting. So we did have a couple instances of that. But I think we can, I think it's safe to say that the V2V and the V2I application themselves, that application functionality required the most attention. So devices were broadcasting as they should be, but the application is where we spent most of our time making sure that everything is working. One other thing too is we need to verify that devices are actually broadcasting on channel 180. We had a couple of instances where RSUs was still broadcasting. In this case, WSAs on 178 and RTCM on 172, and the OBU responded appropriately. So on the surface, everything looked great, but when we started digging into it, realized that the data was being exchanged on the wrong channel. So we really got to pay close attention that the devices are broadcasting on the correct channel. So with that, I think next slide, Kate, that should be it. I know we only have a couple of minutes, but we will open it up to any Q&A. Anybody has any questions? I guess while we're waiting, I want to thank you, Kate, for running the slides for us. And again, apologize for my poor internet connection, but I think we got through it.
So you want me to apologize for my poor city computer they assigned me?
Okay. So Tom, are you actually in the WSP office, you said?
I am actually in the office today.
Oh, here we go.
He's a rock.
So we have a question. What sort of challenges did you face with the SCMS integration in testing? That is that's kind of a long story. The OBUs are enrolled in the SCMS at the factory, and then so when they show up.
Oh, we lost Frank again. Go ahead, Tom. You can finish.
Okay, well, I need to read the question myself. I was just trying to find it. So yes, so from an SCMS standpoint, we have a couple of things that were going on that we discovered. One is, because we are using the signal request message for fire, police, transit, and freight, we needed to be able to distinguish between those messages. And so that it required us to use SSP as part of the PSID. But the other challenge we encountered is that, because a lot of the OBU vendors are building towards OEMs and not towards aftermarket in the sense of a transit agency and so on, the thought of a multi-PSID, multi-certificate OBU was not really on the high priority roadmap. So we were unable to use identity certifications in this model, but instead we had to go to a model that used a pseudo cert with a different expiration period and the additional PSID and SSP to be part of that pseudo cert. Frank, are you back? You want to add anything more to that? Did you catch anything?
Yes, I am.
Okay. Very good.
Yeah,
so,
I caught your discussion on the pseudo cert, so I think that's good. Thanks.
Right. Any other questions?
Apologies. Okay. So it looks like we are at time. All right. So I appreciate everybody's attention, and again, if you have any further questions, feel free to reach out, and we will respond as appropriate in writing. Okay. All right. Thank you, everybody, and have a good rest of your day.
Thank you.
Thank you.
Everybody.